So for scale 12, my A value was 90 miles per hour, translated, which can be converted to 132 feet per second. And my B value is 300 feet. So I wrote the equation down here, and then over here I put in the initial velocity, which was 132 from over here, and then I added the 3 for the initial height, which was given. And then I plugged in 0 for y and 300 for x because they said that over 300 feet the ball would hit the ground. So when the ball hits the ground, the y would be 0 because it's the ground, and then the x would be 300 because it's 300 feet over. So then I manipulated this equation and changed it so that it would be t equals something. So t would be on one side by itself, and then changed it and then simplified it over here. And then I substituted that into the y portion of the equation to get this. And because secant squared plus tangent squared is, or tangent squared plus 1 is secant squared, they have a relationship, so I changed sine over cosine into tangent, and 1 over cosine squared into secant squared, which is right here. I then multiplied both sides by 1089 right here. And then I substituted in for secant squared 1 plus tangent squared because they're equal to each other, which is over here. And then I changed it around so it's tangent squared plus a number. And I solved for the tangent of theta over here. And then I ended up getting 16 degrees and 73.3 degrees. I then used these angles and plugged them back into the original time graph, or time equation, to get 2.364 seconds and 7.9 seconds. And because 7.9 seconds is really unreasonable, the angle is 16 degrees.